So I have another question that I want you guys to solve. I think you guys can just page along. Question number 4. So if you go into your notes, we were on page 11 just now, so I'm sure it's somewhere around there. Okay, question number 4 you're going to find on page 11 as well. Please try that question. Okay, great house. I hope most of you are done or close to done. If you're not done, then we're at least going to establish if you're on the right track. We have a lot more questions that I'd like us to go through, so I'm sorry to rush you, but we're going to continue. Okay, so the first question said a learner prepares a solution of sodium hydrogen carbonate. Okay, and there it is. The resulting solution is a base. Explain with the aid of a relevant hydrolysis reaction. Now, fortunately, all of you know what hydrolysis is, so that's very good. Why the solution is a base. Now, if you take a look at the table above, you're going to notice that this part is not in the table, but something else is. Do you all see that sodium is over here? And sodium does not undergo hydrolysis because it is the ion from a strong base. So based on that, we know, even if we don't see this in the formula, we know that this is the substance that we're going to be dealing with. And therefore, the answer that you guys should have is like this. So you should have said, now I see in the memo, you guys are going to get the memo tomorrow, but there is a bit of a mistake. It should be HCO3 minus, I don't know why the 3 and the negative is not there, plus water. Most of the time, even now, you're going to get a mark for your reactants is going to form H2. So this over here is behaving as a acid or base. Okay, all right, it is going to be accepting a proton, therefore it's our base, and in the end we end up with a whole lot of hydroxide ions. So we write down the formula. In the past exam, I saw that they did not penalize if this was not there, so if you use an arrow in one direction, it should be okay, but we say it's due to the formation of the hydroxide ions. Okay, please don't confuse your hydroxide and hydronium ions, it's very easy to do so. Are there any questions? Are we happy? Okay, moving on. Now this one I think may have been a little bit more challenging, or a lot more challenging. They say the learner adds. Now everything's important, everything's there for a reason. They say the learner adds 25 centimeters cubed of the sodium hydrogen carbonate with a concentration of 0.1 mole per decimeters cubed in an Erlenmeyer flask. If it helps you, go and draw pictures. Don't be scared to draw pictures, they help a lot. They say the solution is now titrated with 0.1 mole per decimeter cubed H2SO4 sulfuric acid solution from a burette. To reach the end point of the titration, the learner needs to add this amount, 12.5 centimeters cubed of sodium hydroxide from the burette to the Erlenmeyer flask, and they gave you the balanced chemical equation. So as you guys can see over here, if you recall from grade 11, when we have a metal carbonate reacting with an acid, we're going to produce a salt, carbon dioxide, and water. Okay, that is from grade 11. They say during the titration, the learner accidentally exceeds the end point by adding an additional 4 centimeters cubed of the sulfuric acid solution. Okay, now they say calculate the pH, but there's just so much information and you're so confused and you're losing your mind. Start off at the top and work your way down. Firstly, we have a beaker and we are adding 25 centimeters cubed to that, or a Erlenmeyer flask. We then go and we add some of this, that is 12.5 centimeters cubed. In adding the acid to the base, please understand that the volume has changed. A lot of you miss that. If you didn't add volumes together in your calculation, you missed that point. Volume in this case is the water, it takes up space, right? And that over there you need to add together. So in the end, this is the reaction that's taking place. Now let's take a look at the salt. When it's dissociated in water, we have two types of ions. The first is the sodium ion, and the second one is the sulfate ion. Do sodium ions undergo hydrolysis? No, they don't. Okay, we've pointed that out many times. How about the sulfate ion? Should I scroll up? Okay, the sulfate ion, over here it is. It also doesn't undergo hydrolysis. Okay, so now your confusion becomes a bit less. What I'm saying, grade 12s, is, if I can go to the right slide, okay, when we add this to that, at the end we have a pH that is going to be 0 because hydrolysis doesn't take place. Now what happens is we have this pretty flask with pH of 7, pH of 7, and then we go and we accidentally add more of this thing. And what is that thing, an acid or a base? It's an acid. So what do we expect? We expect our solution to become acidic. All right, don't try to take it all in at once and draw pictures. We don't have to be an artist to do so, but draw pictures. It's going to help you. When it comes to the hydrolysis of salts, that is very important, and that's what we often miss. We often teach acids and bases very, very quickly, and we don't spend a lot of time on hydrolysis, but that is what gets to you guys in your exams. So based on that, this is what you guys should have done. Number 1, we notice that we have excess acid, right? Depends on how you want to calculate, using the method on the left or on the right, but we realize we've added excess acid. The excess acid is the 4 centimeters cubed of the acid, which has a concentration of 0.1 mole per decimeter cubed. That is what we have added, the extra acid. By the way, let's just quickly write out the reaction. If we have H2SO4 and it reacts with water, what are we going to form? SO4 2 minus sulfate ions. Guys, if you don't know your polyatomic ions, it's grade 10 work, you better learn it. Plus H3O plus. Is my equation balanced? It's not balanced, okay. So we need to balance the equation. I hope that I did not make a mistake. Let's see, 2, 2, 2. I hope I'm not going to embarrass myself here by trying to balance this. We have 4 and we have 6 and now we are fine. Thank you. Okay, so now it's balanced, right? This acid, we have different types of acids and I have included it over here. We have monoprotic and diprotic acids. What does it mean for an acid to be monoprotic? It has only 1 proton to donate. If it is diprotic, it has 2. Now this, is it monoprotic or diprotic? Diprotic. So a lot of you missed this if you were writing the Gauteng paper. My learners, a lot of them missed this. If you have a diprotic acid, for every 1 mole of acid, we're going to produce 2 moles of hydronium ions. So step number 1, we know now that we are dealing with this acid, right? We've added an excess of that acid, but the volume is not 4. We have 25 centimeters cubed plus 12.5 centimeters cubed plus the 4 centimeters cubed. Is centimeters cubed the correct unit to work with? No, so make sure that you do your conversion. We're going to divide by 1,000. So firstly, we calculate the number of moles of acid that is in excess. This formula has been manipulated. When you have only 3 variables in the formula, normally we find it okay to manipulate the formula. It has a concentration of 0.1, and over here we have 4 times 10. Ooh, I made a mistake, sorry. This over here, sorry grade 12s, we're not there yet. We're just trying to calculate the number of moles of acid that was added. So now we're first using the 4. When we are done calculating the number of moles that we added, now we would like to determine the concentration of the acid. Remember, we have taken that number of moles of acid and we have added it to a new volume. So now we take that number of moles and we're going to divide it by this volume. This volume we calculated by adding these 3 volumes together because the volume has increased, right? When we are done with that, this is the part that a lot of you miss. Why are we multiplying by 2? Because it's diprotic. Okay, we understand now that our H2SO4 is going to produce 2 mole of hydronium ions for every 1 mole of it, right? So we multiply by 2 and we get the concentration of the hydronium ions. We then know that pH is equal to this formula. There should be a negative at the front. That's a mistake. You get a mark for your formula, so please write it down. And we substitute and we get a final answer of 1,71. Please remember pH does not have a unit, so don't give it a unit. Are there any questions? We're fine. Okay, you guys are going to be given the memo tomorrow. Okay. All right, electrochemistry. How do we feel about electrochemistry? Like this, like this, like this. Where do we stand? We're okay with electrochemistry, so should we skip it for now? Okay, I just want to ask you guys one question on electrochemistry. It is not in your notes. Firstly, let's just do a bit of fixing. Yes?
Can I please ask the question based on electrochemistry?
I hope I can answer it. Yes.
So like, let's say we increase the reactants.
Yes.
Why? I think the EMF will
Reactance EMF is going to increase. So it's based on your Le Chatelier's principle. So in your notes, here it is. So if you go to the section titled galvanic cells, you're going to see over here, you're basically just dealing with your cell potential or your galvanic cell as you would in what is it called? Chemical equilibrium. We're merging the two together. So in order for us to have a high cell potential, right, we would like to favor the forward reaction. And how do you favor the forward reaction? By adding reactants or adding products? Adding reactants. Okay, so if you would like the cell potential to increase, and here we're speaking of the initial cell potential, you're going to increase the concentration of the reactants. Alternatively, you could perhaps decrease, but I don't see it over here, the concentration of the products, right? But normally we would increase the concentration of reactants and then we will have a higher EMF. Okay. Now just over here, have any of you tried this question? It's not in your notes. This is from last year's September paper. Have you tried it before? Okay. The comma over here, why is there a comma in this question? What is the comma for? The phases, yes. I had a lot of learners last year who messed this up. So you guys know over here we have the anode, okay? So, right, we have the oxidized species. It's over here as well. It's in your notes as well. What is this guy? The salt bridge. You actually get a mark for the salt bridge. So if you don't know how to write down your cell notation, please just write something down and at least add in your salt bridge, because you're actually going to get a mark for just the salt bridge. Then on the right hand side we have this. Now the reason why there's a comma there instead of just a straight line is because of the phases. We use this to separate or to show that the phases are different. An electrode is normally solid. Do you guys agree with me? Okay, then we have an electrolyte, and an electrolyte, in what phase is our electrolyte? Aqueous. Over here on this side, right, we have the substance that is going to be reduced, and we have the reduced species. So these two substances are in the same phase, and therefore instead of separating them with a straight line, we separate them with a comma. My learners, or some of my learners last year, thought that both of these were going to be reduced and they were going to form the Y. What do you guys think the Y is over here then? Yes, okay, it's an inactive electrode. We are taking one substance, right, and we are forming another, but they are both in the same phase. Can you have an electrode made up of an aqueous solution? No, you need a solid. So this over here would be an inactive electrode made up of carbon or platinum. Is your hand up? Oh, okay. Made up of carbon or platinum. Are we happy, guys? If you see anything like this, don't allow it to confuse you, especially if it's in your final exams. Okay, so you're going to see there's a whole lot of notes included on electrochemistry. I would like you guys to please try question number 2. I know you guys say that you're very comfortable with electrochemistry, but I would really like you guys to try question number 2. Electrochemistry, if I'm not mistaken, is towards the end. So if you go to page 13, you're going to see question number 2. And the reason I'd like you guys to try this question is because there's a question on acids and bases, or that links electrochemistry to acids and bases. So if you guys can try it and at least get question 2.2, it will be really great. In your summary notes, there are a few things we need to correct. So before you guys get started, here is the first page on galvanic cells. Maybe some of you have already identified the mistakes. I hope so. And then here is the next one. Are you guys all familiar with panic? Anyone who's not in my class familiar with panic? Okay, it's just about remembering which electrode is positive and which one's negative, because it swaps for galvanic and electrolytic cells. So when we get to electrochemistry, it's the end of the year and we all start to panic. So you're going to remember that the electrolytic cells is the last topic you do in the year where you start to panic. With your electrolytic cells, you have a positive anode, P, positive anode, negative cathode, NiC, negative is cathode, and you guys will know if panic is for electrolytic cells, then for your galvanic cells it's the other way around. But please remember, oxidation still at the anode and red cat, reduction at the cathode. That doesn't change. Have any of you identified my mistakes? Okay, there are some big but rather unnecessary mistakes in these notes. So first mistake, can you see over here by standard temperature? That is not the standard temperature. This is the temperature you're going to see in your table of constants, but it's not the standard temperature. It should be 298 Kelvin. Please go and change that right now. The second mistake, you should have H2, not H big 2. And then I just want to point out to you guys, please do not use abbreviations when you use this formula. You must use the whole formula and write it down as it is on your formula sheet. If you guys say E cat E N, or you say E red E ox, you're not going to get your formula mark. So you must write down these formula exactly as they are, these formulae, sorry. Okay, so on that note, I would like you guys to please try this question, question number 4. No, 2, sorry, question number 2. Okay, so they said, yeah, the diagram below shows the apparatus used during electrolysis. Electrolysis, a galvanic or an electrolytic cell? Electrolytic, okay, so that's very important. They now say the concentration, or a concentrated, sodium chloride solution at 25 degrees Celsius. Did I make a mistake? The diagram below shows the apparatus used during the electrolysis of a concentrated sodium chloride solution using carbon electrodes. The balance equation for the net or overall reaction is as follows. Okay, now over here, why did they mention that it's a concentrated sodium chloride solution? Why is that important? Do any of you know? Because it's very important, and you guys said you're very good at electrochemistry, so now I'm worried. Okay, if you go to these notes over here, you're going to see that I have a summary for you, okay? On this page, unfortunately they're not numbered, but I think it's the very last page in your document. You're going to see at the bottom left-hand corner, we have the decomposition of copper to chloride, and on the right-hand side, we have the electrolysis of concentrated sodium chloride. These two electrolytic cells often cause confusion, so it's very important that you guys study them and know how to answer the questions about them. Okay, so if you look over here at the bottom, I think I did include it over here as well. Here it is. We have, it says over here, A high concentration of chlorine ions are oxidized more easily than water. Normally, right, if we did not have a high concentration of chlorine ions, the water is the substance that would be oxidized. Okay, it is a better reducing agent than chlorine. And if you go and you look at your table of standard reduction potentials, you're going to see that water is a better reducing agent than chlorine ions. But when we have a concentrated solution of chlorine ions, they are going to be more easily oxidized than the water. That is very important, and that is why that has been included. Are we happy? Okay, so over here they said write down the name of. You all said you're very good at the section, so what is X? It is a battery, a cell or a battery, right? This is an electrolytic cell, so we're using electricity to drive a chemical reaction. They said the formula of the gas at A. Now over here, there are little clues or little things that you guys can use in order to help you. Remember I said panic. Okay, so coming back to panic, panic is going to help you when you start to panic. Panic means positive anode. What takes place at the anode? Oxidation. So over here we have an ox. And over here we have negative cathode, right? Red cat. That is what panic is going to help you with. So based on that, the formula of the gas that is going to be produced over here, in this case, our chlorine ions are going to undergo oxidation and form chlorine gas, while our sodium ions, no, not our sodium ions, our water is going to undergo reduction. Okay, so at the anode oxidation, we're going to have chlorine gas being produced. Okay, are we happy? Any questions? Okay, we have chlorine gas. They say the half reaction taking place at electrode Q. Over there, you're welcome to make use of your table of standard reduction potentials. But even if you take a look over here, I have included this for you. So go and learn that this over here, whenever you have the electrolysis of sodium chloride, this is going to be your reduction half reaction, right? And over here we have H2O plus 2 electrons forms H2 gas plus OH minus ions. Okay, last question. They said the formula of the reducing agent. Is the reducing agent reduced or oxidized? It's oxidized. If it gets oxidized, does it gain electrons or lose electrons? It loses electrons, and it is our chlorine ions, specifically the ions, that are undergoing, in this case, oxidation, and is therefore the reducing agent. Now please, when you guys wrote this down, make sure that if you're using the chemical symbol, you must have a negative there. If you just wrote down Cl, it's going to be marked wrong. If you wrote down Cl2, that is the product, it is not the reducing agent. So make sure that you write down the reactant. Then came the next question: which one of the following correctly describes the concentration of hydronium ions? So now we have acids and bases in your favorite topic, electrochemistry, right? And they say, which one of these correctly describes the concentration of hydronium ions, H3O plus? I'm sorry that this is not correct. It should be a small 3 or subscript 3 in mole per decimeters cubed in the electrolyte after the reaction has run to completion. Taking a look at that reaction, the one that I made you guys write down because it's not in the notes or in the question. What is being formed? Are we producing hydronium ions or hydroxide ions? Take a look, take a nice look. Here is the formula, or the reaction, sorry, I keep saying formula. Here is the reaction that is taking place. We are producing as products chlorine gas. The chlorine gas is a gas, so if, in this case it's not an open container, but if it were open, it would escape. We have hydrogen gas, and then we have this. What will sodium hydroxide do in water? Beyond that, what is it literally going to do? What's it physically going to do? It's going to dissociate. Just like salt, table salt, sodium chloride, when you put table salt into water, it dissociates, it breaks apart. This sodium hydroxide is not stuck together. Okay, the sodium hydroxide is dissolved. If we wrote down the phase, it would be aqueous. And in solution, we actually have Na plus ions floating around, and we have OH minus ions floating around. Which one of these two reminds you about acids and bases? Mostly. This one over here, we remember this, right? When this is produced, when the hydroxide ions are produced, do we have an alkaline solution or are we producing an acidic solution? Okay, we have a base, nah? We have a base forming. So, based on that, over here, is this answer correct? Or must I help you guys think a little bit further? They say over here, so the answer is H3O plus is going to be bigger than 1 times 10 to the negative 7 because the solution is alkaline. NaOH is formed. What's wrong about this answer? We have produced, remember, we have a base. So we have produced a whole lot of OH minus. If we are producing a whole lot of OH minus, is the pH going to be high or is it going to be low? It's going to be high. Now coming to the formula that we use for, the autoionization of water. We know the autoionization of water at 25 degrees Celsius. When you multiply the concentration of the hydroxide and hydronium ions, we end up with 1 times 10 to the negative 14. If you go all the way back to the question, I'm sorry that I'm scrolling so much, but if you go all the way back to the question, notice that they actually mentioned that this is taking place at 25 degrees Celsius. That's important. That is there for a reason. It can give you a bit of direction because this formula that is also on your formula sheet happens to work at 25 degrees Celsius. So we are producing a whole lot of this. This is constant. We're producing a whole lot of this. What is going to happen to that if we're producing a whole lot of this? It's going to go down. Okay, if you say 1 times 10 to the negative 7 times 1 times 10 to the negative 7, you're going to get 1 times 10 to the negative 14. When the pH is 7, then we're going to have this concentration and that concentration are both 1 times 10 to the negative 7. But in this case, we actually expect this to be low. Okay, it needs to be lower than that. And the reason is because we have an alkaline solution. Are we okay? Are there any questions? Right, acids and bases, you guys did mention acids and bases is trouble. It can come into your favorite topic, electrochemistry. Is there any confusion? Okay, so what did we do? We realized that we are producing a whole lot of hydroxide ions. If the hydroxide ions go up, then this must go down. It's no longer 1 times 10 to the negative 7, it's going to become smaller. Okay. Over here, now they said the electrolyte NaCl is replaced with copper chloride solution. The following observation is made about the product formed at the electrode. When copper chloride solution is used, a metallic product is formed at Q, but there is no metallic product at Q when NaCl solution is used. Explain this observation. What is the reason? What's going to happen? Why do we have a metallic product forming when we have Cu2 plus in solution? What's going to happen to that Cu2 plus? It's going, not oxidized, reduced. It's going to be reduced. So in the end, the copper 2 plus ions are going to be reduced. When they are reduced, they're going to form copper solid. We say that the copper 2 plus ions are stronger oxidizing agents than the sodium plus ions, and therefore they're going to be reduced to copper. Okay, and that is the reason why we have the solid forming on the electrode. Are we happy? Are there any questions? Okay, we can then move on to chemical equilibrium. How do we feel about this topic? Great. Okay, I see a few thumbs that are down. So let's start off with question number 1, which I think is, yes, it's multiple choice, and question number 2. When we're done with that, I'm very sorry to the Gauteng learners, but this was actually included in my notes before you guys wrote your trial exams. Because this comes from a past paper, and believe it or not, I actually made my matrics write this last year, and then it came up this year. Okay, so I'm going to go through this as well. Please try question number 1 and 2. If you are waiting, try question number 5 so long as well. Okay, grade 12, let's have a look at the multiple choice questions, and then I'll give you a bit more time for the longer question. Okay, question number 1, they say the equation below represents a reaction at equilibrium. We have on the left hand side that the solution is yellow, on the right hand side it is orange. Which one of the following will change the color of the mixture from orange to yellow? Okay, now firstly I want to go to question or answer C and D. Notice that they speak about pressure. Pressure, can we use pressure, or can we change the volume and influence equilibrium if everything is aqueous and liquid? No. Pressure is about gases. Remember, pressure is the amount of force that gases are exerting on the walls of a container per unit area. So already we know that we can eliminate these two answers, okay? Pressure is about gases. That's very, very important. Now, sodium hydroxide, remember we spoke about salts dissociate. Sometimes it seems like salt, table salt, the one that you put on your food, is the only salt that we have, but understand that over here, NaCl, just like table salt, when you place it into water, it's going to dissociate. That means it's going to break apart. So grade 12s, when we add sodium hydroxide pellets into this, it's going to dissociate into Na plus ions and OH minus ions. Over here we have HCl. HCl, is it ionically or covalently bonded? I need an answer, please. Is it ionically or covalently bonded? Covalently bonded. All right, grade 10 work. Ionically bonded, covalently bonded, very important. I know this will dissociate because sodium is a metal and it's bonded to a polyatomic ion. So when you place the salt in water, it's going to dissociate. It's just going to break apart. To dissociate means I no longer associate with you, so everything just breaks apart. But if we look at HCl, is hydrogen a metal or non-metal? Non-metal, right? It is on the left-hand side of the periodic table, but we know it's non-metal. How about chlorine? Non-metal. When non-metal and non-metal bond, we have that they share electrons, therefore they are covalently bonded. So when you put HCl in water, it's not just going to break apart, okay, because that's not its nature. Your ions will break apart, but this does not consist of ions. Instead, this is going to react with the water in order to form Cl minus ions and H3O plus ions. We say that it ionizes, okay? So your ionic substances dissociate. Your covalently bonded substances, specifically your acids, they're going to ionize. Do you need to? Okay, they're going to ionize. So in this case, when I put HCl into the solution, it's going to produce Cl minus ions. When I put sodium hydroxide into the solution, we're going to produce sodium and OH minus. Alright, now if we take a look at this, can you see this H plus? Does everybody see that? You all know H plus ions are often referred to as protons, and they can't exist on their own. Normally they exist in this form. Do you agree with me? Okay, so in the end, if we add this or that, notice we don't have sodium or hydroxide ions, yes, in the solution, but we do have H plus ions. So if we go and we add HCl, we are actually increasing the concentration of that. And if we increase the concentration of reactants, what reaction is going to be favored, forward or reverse? the forward reaction. And look, our forward reaction is going to change. Did I make a mistake? I think I did. Which one of the following will change the color of the mixture from orange to yellow? I thought it said yellow to orange. What answer did you guys write down? Did you write down the first one? Oh yes, that makes sense. Yes, sorry, I had a bad moment there. Okay, so we know that this won't work, but over here, if we add this to the solution, our H plus ions are going to react with the OH minus, and therefore we're going to reduce the amount of H plus in solution, and we know that the reverse reaction is going to be favored. Our solution will therefore go from orange to yellow. Okay, don't have a moment like me in your exams. So the correct answer is A. Are we okay? All right. Now, when it comes to Le Chatelier's principle, please watch out for this. Some of you make this mistake all the time. We ask you guys to explain why something happens, and most of you just go and write down Le Chatelier's principle again. Don't just go and say that the system was disturbed. Tell me how it was disturbed. Tell me, did we increase the concentration of reactants? Did we increase the pressure, etc.? When you are done with that, tell me that the system will oppose it by doing one of these two things, and tell me why. Okay, so tell me what is going to happen specific to that reaction. Some of you, like I just said, go and restate Le Chatelier's principle. And then tell me which reaction is going to be favored. Some of you missed that as well. Normally 3 marks. Remember your bullet points. Now Kc. Kc, in very simple terms, your equilibrium constant, actually just tells you, are we going to produce a whole lot of reactant, or are we going to produce a whole lot of product? That is what it actually tells you, and most of you miss that. The only thing that affects Kc is temperature. Okay, only the temperature. Over here, if you look on this table, this is in the summary notes. Okay, if you go to the equilibrium section, chemical equilibrium section, you're going to see here where we have changes in temperature, your Kc value is going to be affected. All of the other things do not affect Kc. Please remember that. Now, over here, your Kc value, this is in your notes. Kc value basically just tells you lot of product, lot of reactant. If you have a Kc value that is bigger than 1, it means equilibrium lies to the right. If it lies to the right, it means we're producing a large amount of products. If you have a Kc value that is, this is a mistake, this should be smaller than 1. Please go and fix that in your notes. When your Kc value is low, when it's smaller than 1, it means that we have a low concentration of products, but we have a high concentration of reactants. In other words, equilibrium lies to the left. Kc has a meaning. We don't just ask you guys to do calculations because we're bored. It actually has a meaning. It tells you whether we have a lot of reactants or a lot of products once equilibrium has been established. You can again relate this to acids and bases. If you're looking at the Kb value, this is fine, yes, Kb value. If you're looking at the Ka value, same thing. If you have a strong base, it will dissociate completely in water, and as a result, its Kb value is going to be high because we're producing a whole lot of product. If you have a weak base, on the other hand, it will dissociate incompletely and your Kb value is going to be small. Kb, Ka, Kc, all just Kc, and they tell you whether we have a lot of reactant or a lot of product once equilibrium has been established. So over here, next question, it says the following reaction is in equilibrium. There it is. Always when you guys have problems on chemical equilibrium, pay attention to the phases. What phases are we dealing with here? Gases. Everything is a gas. Very important. They say the relative amount that is the yield of XY can be increased by. Now some of you, when you just see gases, you immediately think pressure. But why is pressure not going to work here? Perfect. There's an equal number of moles of reactant and product. Whenever you guys have gases, right, remember You're going to look at your reactants. Remember, this is the balanced equation. 1 mole here, if it's not written, it's like in math. If you have x, you know it's 1x. Over here we have a 1. So what is the total number of moles on this side? 2. On this side we have 2 as well. So neither reaction will be favored because both produce 2 moles of gas. If you're going to increase or decrease the pressure, it's not going to do anything here. Okay, so already we can eliminate these 2. Now on the right hand side we have this symbol that is smaller than 0 that you learned about in grade 11. What does it mean? Exothermic. Okay, here we have an exothermic reaction, and we know that if we would like to produce more of this and the reaction is exothermic, what do we need to do? Decrease the temperature or increase it? Decrease it, because then our reaction will want to produce more heat. If we go and we decrease the temperature, right, then the reaction's going to favor, or the reaction that will be favored is the one that will increase the pressure. And since this over here is an exothermic reaction, we're going to decrease the temperature, making the correct answer A. Okay, we have 6 minutes left. Continue. Yes? Okay, so over here I just quickly want to run through how you guys should look at it. We won't actually answer all of the questions. You don't often get graphs, but some of you really struggle with these graphs when it comes to your chemical equilibrium. So in the notes, I just made notes that are in red and blue, I hope. Over here, if you look at this, it refers to the table, which you guys of course have in front of you. And I was basically saying that pressure, if we are looking at pressure, changing the pressure is going to affect the concentrations of all gases. Whether the gases are reactants or products, they're going to be affected by change in pressure. Pressure, you guys learned about Boyle's law last year. When our volume decreases, the pressure increases, and all gases in that container are going to be affected by that volume change, whether they are reactants or products. So look out for this when you have substances that are in the gaseous phase and you're dealing with a concentration versus time graph. But when you are dealing with a graph of reaction rate versus time, then what you guys must look out for is temperature. Temperature, if you have an increase in temperature, the rate of both the forward and the reverse reaction will be favored. And what's the reason? Why do both of them increase? Grade 10 work. Okay, you guys learned about the kinetic molecular theory. If we increase the temperature, particles start to move more. In grade 12, you learned about collision theory. If they are moving more, they're colliding more. They have more energy, possibly energy bigger than or equal to the activation energy, so they can collide effectively per unit time. All right, so in this graph, the first question says, identify the changes made to the mixture at 2 minutes and 6 minutes respectively. Let's start off with 2 minutes. Here's 2 minutes. This graph continues to go up like that. Let me just make sure that I'm highlighting the correct one. This one over here is going to go down and that one's going to go up. Is this a concentration versus time graph or reaction rate? What are we looking at? We're looking at concentration. Okay, so activate concentration, brain. When you have concentration versus time graphs, they are a bit more confusing. So what I want you guys to do is in your exam, use a highlighter, use a colored pen or whatever, and you're going to highlight your reactants one color and you're going to highlight your product one color. So in this case, our reactants are N2 and H2. So here is N2, that is its graph. And we have, did I say H2? Yes, here's our H2. All right, they are overlapping, which makes it very confusing. We're almost done, guys. So at 2 minutes, what is the immediate change that you see? Where do we see a spike or something weird happening? Which one of the substances? N2. Now, if only one of them changes, and we are looking at a concentration versus time graph, it means the concentration of that substance has increased. So we will therefore state specifically, please, that the concentration of N2 was increased. Okay. Now we come to the 6 minutes. The 6 minutes is over there. Notice when we are looking at the 6 minutes, this over there goes up like that, that goes up like that. Now you have two things left. We know it's not concentration because we don't see any spikes. But if we look at this, can you see that we're dealing with gases? Does everybody see that? How many mole on the left? 4. 1 plus 3, 4. And on the right we have 2. So over here we notice that the concentration only of the reactants goes up. And we notice that over here our product is going down. So can this be a change in pressure? Pressure affects both. Okay, so over here I said your concentrations, remember pressure is related to concentration, and if we are looking at gases, the pressure is going to affect both, because when you increase the pressure, the concentration is going to increase. So in this case we're actually looking at a temperature change, because what type of reaction is this? It's an exothermic reaction. The forward reaction is exothermic, so the reverse reaction is endothermic. And since our reactants are increasing, which one was favored? The reverse reaction, and therefore we can say that there was if we are increasing, it's going to be a decrease in temperature. Okay, grade 12, I'm going to end here because it is now 6:30.